Good afternoon, everyone. We're just going to give another minute or two for everyone to log on, and then we will get started. Good afternoon, everyone, and welcome to our presentation today. We have two webinars today, back to back. Our first webinar is entitled Endothermic Wraps, Thermal Protective Systems, and our second webinar today is the basics of perimeter fire containment. My name is Christina Larkin, and I will be one of your moderators, along with John Zalepka, who is our Training and Development Manager. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We will be disabling the chat feature during this session. Questions can be sent in the Q&A section at the bottom of your window. We will be gathering your questions during the webinar and will hold a question and answer discussion at the end of each webinar. We will be reporting AIA credit for those of you who attend at least 75% of both live webinars. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, STI will be sending certificates of attendance for you to self-report to whatever agency you wish. In addition to your certificates, STI has partnered with Credly to provide you with a digital badge of your credentials. Digital badges can be used in email signatures, digital resumes, and shared on social media sites. We will also be sending a recording to all who registered. Please allow 7 to 10 business days for the generation of certificates, badges, and recording.
Thank you, Christina. Fire-rated shaft enclosures are perhaps one of the most important features of modern high-rise construction. From fire alarm cables to fuel oil, rated enclosures are imperative to the life safety of a building's occupants. Our presenter today is Dan DeSantis, ERAP Specialist and National Accounts. Dan is extremely familiar with these thermal protective systems. As a former project manager for one of the largest insulation contractors in New York, he has had many years of experience installing endothermic wraps on some of the most prestigious projects in the world. This material has been developed by Specified Technologies and is copyrighted, so please do not reproduce, redistribute, or display any material without contacting us first. As was mentioned, this course has been approved for 1 AIA LU HSW, and the course has also been registered with ICC. As part of the continuing education requirements, here are today's learning objectives on the screen. And in order to receive credit, be sure to stick around at the end of each presentation where you'll be asked to participate in a poll that will test your knowledge of these learning objectives. And here they are. At the end of the program, you'll be able to recognize the new code requirements as it pertains to the shaft enclosures. You'll be able to identify the events that led to the code changes. You'll be able to define the acceptable methods for shaft containment. And finally, you'll be able to describe fire-rated shaft enclosures for in-building fuel oil piping system. And with that, I'll turn it over to Dan DeSantis, who will take us through this part of the presentation. Welcome, Dan.
Okay, thank you so much, John, and thank you guys so much for being here. As John says, I'm the National ERAP Specialist for STI Firestop. And today we will be covering thermally protective systems, what they are, what their uses are, some of the alternatives, and in-building wireless communication systems. fuel oil line protection, and then, of course, some of the systems and examples for each. And we will take your questions at the end, so feel free to type them into the Q&A portion of the chat, and we will address them as they come. This graphic here gives us good perspective on how thermally protective enclosures are utilized in modern construction. All of these services, from fire alarm cables to smoke extraction fans, utilize passive fire protection in order to maintain their circuit integrity under the extreme temperatures of a building fire. We'll be focusing closely today on in-building wireless communication systems as well as mechanical fuel oil piping. But as you can see, there are many use cases for passive fire protection, and most are related to circuit integrity. Thermal protective systems are passive in nature, meaning that they live inside of the building, require little to no maintenance, when properly installed, should maintain their integrity for the life of the building. Traditionally, we have seen this accomplished in three ways. Cast-in-place concrete, where electrical pathways are completely immersed in thick concrete to prevent the heat of a building fire from interfering with the circuit's operation, as well as a fire-rated gypsum wallboard assembly, commonly referred to as a drywall shaft enclosure. Last and certainly not least is endothermic wrap, which is a thin and lightweight material used as a shaft enclosure and protection of the building surfaces. These wraps can provide an hourly rating of up to 2 hours where a traditional means of construction may not be possible. It's important to note that not all endothermic wraps are created equal, and it's imperative to know that the standard to which a particular material is tested is before you install. Let's have a closer look at cast-in-place concrete as a protective enclosure. While concrete makes an excellent fire-rated barrier for vertical and horizontal separations like walls and floors, it lacks the versatility to provide reliable conduit enclosure due to its difficulty to visually inspect once set. And once it is set, making adds, moves, and changes is virtually impossible. This is a problem for the life cycle of a building, as upgrades and changes in technology are a way of life in modern construction. Additionally, there's no test standard for cast-in-place concrete as a thermally protective enclosure. No test standard means a wide array of possible outcomes across different manufacturers' products. This should be a concern to specifiers, as a product may not perform as intended. This graph here, published by the NFPA in 2008, shows the temperature performance of cast-in-place concrete. The test was performed using the Astm E119 time temperature curve of a typical cellulosic fire. As you'll see noted here, the unexposed side of 2-inch thick concrete reached 675 degrees Fahrenheit after 2 hours, while 4 inches were required to maintain a passable temperature of about 325 degrees above ambient, or 400 degrees total. As we can see, cast-in-place concrete is not without its limitations. Concrete encasement is difficult to inspect. It's impossible to re-enter without demolishing, and carries the risk of spalling before fully cured. 4-inch encasement is not practical for most applications due to its weight and labor-intensive installation. It's great for some applications like fire-rated barriers, but for thermally protective enclosures, it's less than ideal. Drywall enclosure for fire rating of electrical circuitry is the next and most common thermally protective enclosures you'll see. This is a plan view of what a typical gypsum shaft wall construction looks like. In this configuration, one side is the 2 layers of 1/2 inch or 5/8 gypsum wallboard, a 2.5 inch CH stud spaced 24 inches on center, and a 1 inch thick core board shaft liner on the reverse. This type of construction is commonly found in MEP riser shafts, elevator shafts, stair towers, and it's a great option for enclosing large shafts or creating area separation walls in both horizontal and vertical assemblies. But one of the biggest misconceptions that we see in the field is that the belief that running conduit inside of the stud cavity of a rated wall will provide that conduit a rating. This simply isn't the case. In the event of a fire, the exposed side of the shaft wall will be sacrificed. The outer layers of gypsum will burn away early on. This is by design. The entire assembly may be rated for 2 hours, but running services within the stud cavity will get you no rating at all. In fact, the temperatures within that stud cavity may rise to exceedingly high temperatures within minutes while the unexposed side will remain unaffected for considerably longer. The correct method for enclosure using drywall is to build a full depth assembly on all sides of the protected item. As you can see here, 3 emergency feeders shown in red are behind the shaft liner side of the wall. The double layered gypsum would be considered your exposed side, and 3 more sides like it must be constructed to have a full 2-hour rated assembly. Although drywall has been the go-to solution for fire-rated shaft containment, it does have its limitations. Access is the #1 issue when using drywall. This is especially important in the retrofit segment, which we'll be discussing a little bit. But can you frame the area that needs to be protected? Think of a busy corridor in a commercial use building. HVAC duct running next to IT wiring, next to chilled water lines. It gets extremely crowded up there. Now try to build a 4-sided drywall enclosure around a 1-inch conduit that lays on a trapeze hanger 2 inches away from a return air duct. Or maybe you have 500 linear feet of DAS cable to protect that snakes around the project. Access can be tough, especially in a city like New York where space is a premium. Since the full depth shaft wall assembly must be built on all 4 sides of the protected item, you could lose finished ceiling height, and access to the inside of the shaft for troubleshooting or upgrades can be problematic as well. The third method we'll be discussing is the use of an endothermic wrap, or EWRAP for short. EWRAP is not just a material, but it's a tested and listed system of a shaft wall enclosure. This is a purpose-built product that was designed for the fire protection of building services. EWRAP is applied in layers corresponding to the required hourly rating of fire resistance. EWRAP can be used on communication hardware for ARCs and DAS systems, as well as fire pump alarm circuitry, signaling equipment, panel boxes, or other mission-critical circuitry as well. Fuel oil line, and it is an extremely versatile product in its application and tested and listed by UL and Intertech for these specific purposes. More on endothermic wrap in a bit. But let's take a look to the past to see how we got here. On the tragic events of 9/11/2001, where over 2,500 lives were lost that day, among them 343 brave souls of the FDNY. If any good was to come of this horrific tragedy, it gave us an opportunity to improve how we construct. A few years later, in 2005, the NSIT World Trade Center report was published. In it, we learned that communication was a huge issue during the events of this tragedy. The convergence of dozens of different departments with no reliable way to communicate with each other once inside of the building. This proved to be a contributing factor to the scale of loss of life. No evacuation orders could be given, no method of distributing information in real time. But 2 years later, in 2007, the National Fire Protection Association published their guide for the in-building wireless communication system. It's a simple solution by today's standard, but a step in the right direction. And not until 2009 did we see the first IFC revision via a new chapter 510, which mandates new buildings have an ERRCS system installed. Then in 2012, the NFPA launched a detailed standard, 1221, which lays out the parameters of the in-building wireless communication system. This standard is still in use today with some minor revisions along the way. In 2018, some slight modifications to the IFC 510 to add that NFPA 1221 reference to the standard for the industry. References to circuit integrity and survivability are made in NFPA 72 of the National Fire Alarm and Signaling Code. The 2019 edition shown here makes mention of circuit integrity for in-building voice alarm systems employing relocation or partial evacuation, and of course our in-building wireless communication systems, also known as ERRCS. Circuit integrity refers to the operability of electrical conduits during the fire. It is a form of a fire resistance rating. Circuit integrity is achieved via passive fire protection, which are subject to stringent listing and approvals for use and compliance. The National Fire Protection Association dictates the parameters that must be met when installing your in-building wireless communication system. Among these is that 95% radio coverage on every floor of your building is required under this code. Under related codes, such as the National Fire Alarm and Signaling Code, 90% of the floor's general building area must be covered with signal, and as much as 99% of the floor's square footage in critical areas, such as paths of egress. Let's talk about wireless coverage. In the same way that we need a router for your home or your Wi-Fi internet signal to cover our houses, in-building wireless communication systems rely on strategically placed emanators and repeaters in order to cover the required square footage of a large building. And FPA 1221 stipulates that no less than 95% of the building's general square footage be covered with such a signal. No signal means no communication, and in the event of a fire, that could translate to loss of life. The National Fire Alarm and Signaling Code has a slightly different standard. They require 90% of that general square footage to be covered, and 99%, such as fire pump rooms, paths of egress, and stair towers. It's important to consult with your authority having jurisdiction on the project to gain a clearer perspective on what's required. NFPA's 1221 is a very broad standard. It covers everything from hardware to coverage requirements for in-building wireless communication systems. But next we'll be focusing on the rated enclosure aspect of the code. There's two specific mentions in the standard regarding rated enclosures, and both can be found in Chapter 9. The first reads, backbone cables shall be routed through an enclosure that matches the building's fire rating. Notice that no guidance is given to the type of enclosure that is required, but only that it matches the building's fire rating. The building's fire rating is most often defaulted to 2 hours for most high-rise construction applications, but could vary from job to job and range from 1 to 2 hours. The standard's next mentions of fire-rated enclosures in the following chapter. The connections between the backbone cable and the antenna cable shall be made within an enclosure that matches the building's rating. This refers to the connection between vertical backbone cables and the horizontal antenna offsets that should be made within an enclosure that matches the building rating, typically 2 hours in most cases. Requirements for in-building emergency radio communication systems were first introduced into the IFC in the 2009 edition as Section 510. Buildings that cannot support the required level of radio coverage shall be equipped with an indoor distributed antenna system with FCC certified signal boosters. That system is otherwise approved. The IFC also added a requirement for existing buildings that did not already have an approved emergency radio communication system to meet the same requirements in effect as new construction within a time frame established by the authority having jurisdiction. The IFC dictates that 95% of a general square footage of a building be covered for public safety. This is significant due to what's known as the retrofit market. Older buildings requiring a new ERRCS system have a much more unique challenge from an execution standpoint. Existing shafts and rated pathways may not be an option without invasive demolition or an extensive review of the surrounding construction. We often look to alternative methods of shaft enclosure like endothermic wrap for these applications due to their complexity and access issues. Under IFC 510, here's what we can expect the world to look like. A retrofit system being deployed in new and existing buildings alike. You see here some examples of the hardware involved with these systems. Vertical donor antennas with strategically placed repeaters to ensure the proper levels of coverage. In these hypothetical examples, both vertical and horizontal offsets would need to meet level 2 survivability for their pathways. This means a fire-resistant enclosure matching the building's rating, which in most cases is 2 hours. So how do we know if a material is suitable for use as a fire-resistant enclosure? Well, we burn it. Using the Astm E1725 standard, a full-scale test is conducted in a burn lab. The temperature curve you see here is called the Astm E119 temperature curve. This simulates real-world building fire conditions. And the same time temperature curve is used for through penetration, joint construction, and curtain wall fire stopping standards as well. They even use this time temperature curve when evaluating the barriers themselves to determine if a gypsum wallboard assembly can carry a fire rating, for instance. This curve helps to achieve a consistent fire rating that serves as a baseline for all systems. Having a consistent test acts as a yardstick to measure against for all systems across all manufacturers. During this test, thermal sensors are placed inside of the enclosure on a bare copper conductor to read the temperature minute by minute. In order to pass this standard, the average temperature rise across all sensors must not exceed 325 degrees above ambient, or 400 degrees total. When you're using endothermic wrap tested to ASTM 1725, you're using a product that is third-party tested to these strict parameters by an independent lab. Although the three cases, we skipped the cases, okay. So talking about the new versus retrofit market. Retrofits have surprises and countless changes are made to the IT and security systems over the years. There's little space for new pathways in these retrofit scenarios. Existing shafts may not be accessible without invasive demolition. Endothermic wrap is a silent installation, meaning no power tools are required. This is ideal for an occupied hospital. It means less disruption to the patient care or an overnight ceiling permit where work won't disturb occupants. EWRAP is also the lowest profile solution for circuit integrity. At just half an inch thick per layer, space becomes less of an issue and your survivability requirements are met without sacrificing finished ceiling height. Structures like parking garages and stadiums also have their own circuit integrity needs. Traditional means of shaft enclosure may not fit the aesthetic for a particular building, especially those with an open ceiling or industrial design concept. Endothermic wrap, as well as providing the required 2-hour rated enclosure for critical path services, it blends into the surrounding mechanicals. It can also be jacketed with colored PVC to fit the desired aesthetic of the project. So here's a summary of what we learned so far about endothermic wrap. It's tested to the industry standard for circuit integrity ASTM E1725. Third-party testing from UL and Intertech labs, as well as unique listing numbers for various applications. The product is highly flexible for use on small diameter conduit and threaded rod supports at just half an inch thick per layer and 1.35 pounds per square foot. It's the lightest weight solution on the market. No additional supports required for weight. And of course, EWRAP gives design professionals the clean aesthetic they're looking for exposed ceiling design concepts. The image on the right is pulled from our Intertech listing for a 2-hour rated enclosure on EMT. We'll be breaking the system down a little bit further in a minute, but this system serves as a baseline for our electrical circuitry solutions. So how does endothermic wrap work? So EWRAP contains chemically bound H2O molecules which absorb energy in a slow and predictable way. Energy is diverted away from the circuit via steam, keeping the temperature inside at a reliable level to maintain circuit integrity of the pathway. Endothermic wrap is applied in layers corresponding to the required resistance rating required. In the image shown here, 4 layers were required to protect this item for a 2-hour fire resistance rating. When we're talking about circuit integrity and survivability requirements, it's not just the conduit that requires protection. Hardware housed in steel junction boxes, such as repeater cabinets and switches, may also need to be protected as part of the system. Having a fully encapsulated system is imperative to the performance of an ERRCS under fire conditions. While it's only strong as its weakest link, which is why we provide systems for various size boxes on different orientations. On the right, we have a typical steel box. This could be part of an emergency DAS system if this oriented against a CMU block wall. Using endothermic wrap, this box is now protected for a 2-hour F rating. You'll notice that in that orientation against the CMU wall, endothermic wrap is fastened directly to the CMU substrate. This saves space on the project without sacrificing any of the needs for the circuit integrity. And not just DAS hardware that requires enclosure. Maybe it's a utility panel or a backup generator or med gas valve box. Either way, endothermic wrap is a tested and purpose-built solution for the protection of these items and will meet the performance requires of the local building code in your region. The sketch shown on the right, shown both in section and elevation view, is a typical panel box recessed into a 2-hour rated gypsum wallboard assembly. Endothermic wrap turns this into a 2-hour rated box and adds very little weight to the overall design. Since it is only just half an inch thick, it doesn't require any additional accommodations for space, where generally only one layer required for these box applications. Here on the right, we have a real-world example of a recessed panel box. As you can see, the material fits neatly into the stud cavity on all sides of the box, and now could either be considered 1 or 2-hour fire-rated assembly and just takes a few minutes to install. We now know how effective an endothermic wrap for circuit integrity is. But did you know the same product is a tested and listed solution for the dedicated shaft enclosure of fuel oil piping? In-building fuel oil piping has become increasingly prevalent due to the use of emergency backup generators. Once thought to be limited to hospitals and other public facilities are now found in many high-end residential towers, as well as commercial settings around the country. Fuel oil presents a unique challenge as it is a combustible liquid that needs to be protected from the threat of fire. Let's take a look at how the code requirements speak about fuel oil and how it should be protected. In the IBC section 403, the code requires that fuel oil lines supplying a generator set inside of the building shall be separated from areas of the building other than the room where the generator is located in an approved method or an assembly that has a fire resistance rating of not less than 2 hours. IBC section 2702 reads as follows. Fuel oil lines supplying a generator set inside of a high-rise building shall be separated from areas of the building other than the room of the generator by an approved method and a fire resistance rating of not less than 2 hours. Further breakdown of this code reveals that any fuel oil piping not located within the same room as the generator or storage tanks must be protected with a minimum 2-hour fire resistance rating. Furthermore, codes like New York City Building Code clearly stipulate that fuel oil must be in a dedicated shaft or one that is not shared with any other services. This can cause some design complications for large MEP riser shafts in the core of the building, as they would not be suitable and not be considered dedicated. So therefore, a shaft within a shaft would be required for these situations. Under the 2014 NYC Mechanical Code, dedicated shafts for fuel oil should not be penetrated or shared with any other piping or ductwork. A completely dedicated shaft is required. Chapter 13 speaks about the piping requirements and states that fuel oil return and vent piping be enclosed in a shaft of 4-inch thick concrete or an enclosure that matches the building's fire rating. Again, in most cases, this would be 2 hours. But please consult the AHJ of your project for the exact requirement. Here's some of the code language for horizontal offsets. Horizontal offsets shall be enclosed in a construction having a 2-hour fire resistance rating. In certain areas of New York City and other areas of the country which are prone to flooding, they may require generators to be located on the roof of the building. This would produce a lot more horizontal offsets as piping would run from the subcellar storage tanks to the rooftop generators. Where piping turns out of these vertical shafts to the next vertical shaft would be considered a horizontal offset. The use of endothermic wrap can be used in conjunction with both CMU and gypsum wallboard assemblies. We'll be breaking that down a little bit further. We currently protect fuel oil in a number of different ways. Gypsum wallboard enclosures are great for large MEP shafts, but since fuel oil is required to be in a dedicated shaft, space and access can become somewhat of an issue. Cast-in-place concrete, much like with electrical circuitry, is an acceptable method, but seldom used due to its weight and inability to re-enter once cured. CMU shafts are commonly used for long vertical runs between floors since they're relatively inexpensive and can provide reliable protection, but not practical for most horizontal offsets or retrofit applications. Before we move on to some more specific solutions, let's recap. Fuel oil required to be in dedicated shafts, meaning existing MEP risers would require a shaft within a shaft for full compliance. If space and cost are important considerations, endothermic wrap may be the correct solution for this aspect of the job. Also keep in mind that EWRAP can be used in conjunction with other methods such as CMU and drywall. In these cases where fuel oil piping exits a traditional shaft enclosure, the penetration would be Firestop, as typical for a through penetration, and endothermic wrap would be butted to that substrate. As we can see here, a large project completed in New York City where a 16-inch wide spill duct enclosure housing several fuel oil lines was enclosed using endothermic wrap. This application blends seamlessly to the surrounding construction, and the code requirements for fire resistance are met. So why would you use endothermic wrap on fuel oil? Well, the code tells us that both piping vertical and horizontal must be contained to a dedicated shaft. These can take up a lot of space, which could be better served on the project. They're often very costly to build if cast-in-place or CMU block are involved. And testing for double and single containment fuel oil systems has been conducted by third-party labs like UL and Intertech. Endothermic wrap at just half an inch thick will save some space for these shaft assemblies, and no additional bracing or reinforcement is required to accommodate the weight of EWRAP as a standalone shaft alternative that fits neatly into the existing hangers and standoffs used by steam fitters around the country. So what exactly does third-party testing mean in the case of EWRAP? We tested this product to the industry standard for fuel oil, which is UL 1489. This is a burn test conducted in UL's lab. Much like the test for electrical circuitry, there are strict pass-fail criteria. In order to achieve UL 1489, the average temperature rise along the protected fuel oil pipe may not exceed 250 degrees Fahrenheit above ambient. And no one sensor may reach 325 degrees above ambient at any time during the test. EWRAP is also recognized by the NYC DOB Office of Technical Certification and Research as an approved method for fire resistance enclosures on fuel oil. This 8-inch double containment fuel oil line gives us a good example of a use case where the finished ceiling height was a major consideration. With traditional methods of enclosure, you may lose considerable height. In this case, the piping was isolated and protected without the need for drywall. It's a great solution for a crowded MER room. So next we'll be speaking about some of the proprietary tested and listed systems for STI's EWRAP. We'll cover some of the specific requirements for installation, as well as some of the project-specific encounters that warrant the use of an engineering judgment. We'll take a look at some of the UL and Intertech listings next. This particular system was tested by Intertech, listing number STI AF12001. This is an all-encompassing conduit system. It's for the use of a 2-hour F rating on metallic conduit. This system allows for 2 different methods of installation. The telescopic method, where layers are offset by 2 inches and overlapped horizontally as layers are installed, as well as the butted seam method, where all layers are applied in 24-inch wide sections and butted against the next. When the butted seam method is used, the bead of LCI intumescent sealant is required at the outermost seam. whereas no additional sealant is required for the telescopic. Either installation is completely acceptable as far as this listing is concerned. It's just a matter of installer preference. Regardless of which method is used, we allow for the use of 1/2-inch banding coil or 16-gauge tie wire on the outermost layer to fasten in place. Banding provides a cleaner aesthetic, whereas tie wire may be a quicker installation, but both would be acceptable under this Intertech listing. On the fuel oil side, UL number FP3 and FP4 are STI's proprietary listings for fuel oil line enclosure. FP3 is used for single containment, where FP4 is for double, but when properly installed, these systems are a standalone 2-hour shaft enclosure under that UL 1489 test standard. Like the previous Intertech system, the material is applied in layers corresponding to the hourly rating. On this 8-inch diameter fuel oil line, 4 layers would need to be installed telescopically to achieve a 2-hour rating. As mentioned, EWRAP is applied in layers. For smaller conduits, sized 4-inch and down, 5 layers are required for a 2-hour rating. For conduit greater than 4 inches, only 4 layers are required to achieve the same 2-hour fire resistance rating. Here's an image showing of a finished installation on a fuel oil line. In this case, the contractor opted for the use of 16-gauge tie wire on the outermost layer, but 1/2-inch banding coil would also be acceptable in this scenario. Regardless of which method is used, banding is only required on the outermost layer. Here's a proprietary listing with UL, WL7307. This is a recessed steel panel box for electrical panel or med gas valve box. 1 and 2 hour F ratings are supported with this system with just a single layer of EWRAP. This system only applies to boxes which are recessed into a 1 or 2 hour rated gypsum wallboard assembly and provide a lightweight solution that doesn't require any additional special tools to complete. Maintain the rating of a conduit or fuel oil line through an opening in cast-in-place floor or CMU wall. CAJ 5437 was designed to accommodate those through penetration fire stopping conditions with a simple LCI and mineral wool solution to maintain the integrity of your barriers when using EWRAP. In this case, an 8-inch double containment fuel oil line exits the CMU shaft directly beneath the floor slab. Using this typical Firestop detail, we're able to support the use of EWRAP transitions from shafts of unlike materials. This is also a great system to maintain the continuity of protection through those cast-in-place floors as well. Here are some of the atypical conditions that we've encountered in the past. The sketch on the right shows a typical trapeze hanger with 4 conduits that can be protected all together in what's known as the common enclosure. Below that is a section view of 3 conduits ran tight against the cast-in-place floor slab. This is a low-profile design that is popular in the retrofit market due to its space efficiency. These conduits are protected with what's known as the Clamshell Method. Layers are half-mooned and mechanically fastened directly to the deck instead of wrapped around the full circumference of the conduit. This is great with your cast-in-place floors and walls because shorter standoffs can be used and finished ceiling height can be protected. For product estimation, our website has an excellent tool to calculate the exact amount of EWRAP you will need. Just fill in the parameters of your project on the left-hand column, and a bill of materials will, with the quantities of all materials used, will be appear at the bottom. Okay, so now John's going to give you a short quiz to test your knowledge on what you've learned so far. So I'm going to turn it back over to him to see what he's got.
That's right, Dan. Thank you. Good job, my friend. We have some questions for you, but we're going to ask some questions to our listening audience first, just to test their knowledge to see how they did. So, Christina, when you're ready. Oh, Christina is ready. She launched the poll. So there it is. I'll read through the questions. Do your best. Answer along as we read. Number one, in-building wireless communications devices were first introduced in the 2009 iteration of the International Fire Code. Is that true or is that false? All right. Number two, under IFC guidelines, what percentage of a building's general square footage is required to be covered by in-building wireless communication systems? Is it 95%, 50%, 100%, or 20%? Number three, all existing buildings are exempt from deploying an in-building wireless emergency communication system. Is that true or is that false? Next one. Number four, in New York City, only the FDNY is permitted to operate the DRC controls of an ARC system. Is that true or is that false? And finally, number five, which is an acceptable method of protecting system components for 2-hour fire-rated survivability? Is that a gypsum wallboard enclosure? Is that concrete encasement? Is it a lightweight endothermic wrap? Or is it all of the above? Just take another moment, do your best, answer along, and we'll close that poll and we'll see how everybody did. So Dan, if you don't mind jumping back to that first slide with the questions there.
Sure.
We'll go over the answers here. Christina will pop up the percentages and see how everybody did. So number one, in-building wireless communication devices first introduced in 2009. Dan, is that true or false?
That is true.
That is true. 84% of you got that one right. Number two, IFC guidelines. What percentage of a building's general square footage is required to be covered by in-building wireless communications? That is 95%. That's right. 76% of you got that one right. Number three, all existing buildings are exempt from deploying an in-building wireless emergency communication system. False is the correct answer there. 87% of you got that one right. Moving on to number four. I don't know if we completely covered this one, Dan. Maybe you slipped it in there. It looks like we got a 50-50. They're not really sure. But in
this one is a tough one.
Next slide, Dan, so we can read along with you there, if you don't mind.
Got it.
In New York City, only the FDNY is permitted to operate the DRC controls of an ARC system. Is that true or false, Dan?
Technically true, but I didn't cover it. Just want to see what you guys knew.
That's right. So is it different? Have you found that it's different in other jurisdictions?
Well, New York City is the only jurisdiction which have their own proprietary system, aka the ARC system. Other jurisdictions refer to it as the ERRCS or the Emergency DAS system, which aren't directly controlled by any particular agency. They're just more for emergency responders. So the other states typically do things a little different. New York City being the exception of the rule, as usual. So they have their own rules, and they only are allowed to be the ones touching those systems.
All right. Well, thank you for providing some context to that answer, even though you didn't cover it. So 42% of you don't feel bad. Now you know the answer. And then the last question, which is an acceptable method of protecting the components of the 2-hour survivability? And that is correct. All of the above. 91% of you got it right. And the other 9% of you didn't get it wrong. So great job, everybody. Looks like we have 100% there. Now, Dan, we're going to get on to some questions for you. And like we always do about this time, we do ask you to give us some feedback. Let us know how we did. Let Dan know how you did. That QR code will take you over to LinkedIn. So if you don't mind giving us some feedback, we always will give away a bag, a little swag bag. So please go head on over there and we'll get into your questions. Christina, do you want to take that first one?
Yeah, sure. First one that came in. Can you paint the EWRAP?
You could paint it. So we've had a lot of clients stencil more often than painting, but you could certainly stencil it if you wanted to label it as a fuel oil line, or if you wanted to label it as emergency DAS hardware. You could certainly stencil it. It's easily paintable. The finish is it's an FSK finish. So it's a, like a nylon or fiberglass reinforced FSK. So it's easily paintable. But yeah, there's no issues as far as that's concerned. Could also be jacketed in any way you want with stainless steel, PVC, thin waterproof membrane jacketing, something like that. Anything you wanted to put on the outside. As long as you can achieve the appropriate number of layers, anything you want to do to the outside is okay.
And obviously get it inspected before you put any of those enclosures around there. Next question here, Dan. I'm going to combine two of these questions. Is the wrap limited to just like EMT steel, or can you provide other engineering judgments for other substrates like maybe PVC or aluminum or anything like that?
So you can use all different types of metallic conduit. Anything basically metal is fine. PVC is not supported with the use of E-wrap. A couple reasons is that it does add some weight to the overall design, and under those fire conditions, things tend to get warm, and the PVC will tend to lose its structural integrity under some lower temperatures than steel. So we don't support the use of E-wrap with PVC right now. Maybe something we could test down the road, but not currently. Anything metallic for the time being should be okay.
All right. Let me just grab this next question for you. They're asking about price, and I know price is going to be difficult. There's different markets, labor, things like that, but they're asking for kind of price comparisons between E-wrap and some of the other conventional shaft conditions that you had mentioned there, and maybe even that they asked about XFR pipe, and I know that there's fire-rated cables as well, but can you maybe speak from a high level as far as price comparison, if you can?
We find that the price is generally very attractive to people, and that's just it's bared itself out that way in the market. People wouldn't be using the product as much as they are if it wasn't, financially, it didn't make any financial sense to do so. So we find that there's definitely some pros to using E-wrap, and cost can be one of them.
All right, Christina, you want to take that next one?
Yeah, can the E-wrap be used outdoor in replacement of regular thermal insulation?
I wouldn't suggest it. It doesn't have the testing behind it to sort of give you an idea of exactly what the R value is for outdoor piping if you needed to have a specific R value per inch. It can be used outdoors. I would recommend jacketing it if you're using it outdoors for a fire scenario, so fire resistance rating. But for just ordinary R value rating, we don't have anything to support it. So I would suggest just using the old school fiberglass.
All right. This next question is pertaining to fuel oil, but it probably can be for the in-building wireless communications also. What about retroactively applied to existing conditions? I mean, when might they have to build these shafts? Probably only when they're doing some major renovation. Is that correct?
Yeah. So specifically for communications, let's say for electrical pathways, if you have an existing building that's not undergoing any renovations or anything like that, it won't trigger the requirements under IFC 510 for the use of a product like E-wraps. Your facility's okay. It's the existing facilities that are undergoing upgrades, new changes. That's when they trigger these code requirements to be enforced, and that's when you would see the use of E-wrap in the existing market. As for the fuel oil side, let's say your building's undergoing a generator upgrade or a retrofit generator project, that would be another use case for E-wrap, where you would need to now protect all the new piping in an existing building. But existing buildings that are 30, 40 years old, not undergoing any new changes, generally don't need to adhere to any of these requirements, except for the state of Florida. The state of Florida is requiring that for all new and existing buildings.
Do the pipe hangers required to be rated?
So only when the threaded rods or unistrut penetrates the enclosure directly are they required to be protected with E-wrap for 2 layers or the equivalent to the number of layers penetrated. So let's say you have a 4-layer system on a fuel oil line, and the hanger prevents you from installing 2 of the layers, but you can apply 2 of them normally. You would then take in the hanger with 2 layers to protect these system as a 4-layer system total. So there's a couple different scenarios where hangers are required, but generally speaking, if they don't penetrate the enclosure and you can protect the pipe or conduit that you need to, then they're not required to be taken in.
All right, looks like we have time for one more question here. And then anybody that's typing questions in, we'll get those over to Dan. He'll be able to answer them offline. But you may have addressed this already, but can all the seams be in one spot? I know there was a couple different installation techniques that you had mentioned. Can you just address that one more time?
Sure. If you're using a butted seam method, then all the layers would go on at once. A roll of E-wrap is 24 inches wide. So you'd put on, if you have a 4-layer system, put on 4 layers continuously, and then butt the next 24-inch section directly to it. So yes, all the seams can be aligned. In that scenario, you would be required to have a bead of LCI at that seam, at that radial seam between the layers. So at every 24 inches, you'd have one caulk joint, the depth of 1 layer of E-wrap, which is half an inch. If you're doing the telescopic, no sealant would be required, but every seam would be required to have a 2-inch overlap, longitudinal and radial.
All right, great job, Dan. Thank you very much. If you don't mind, let's roll through the last few slides. This way we'll be able to give our listening audience here a 5-minute break before we get to the next presentation there. So we just want to start with putting up Access STI on there. This is a QR code. It'll take you over as a Firestop manufacturer that only is dedicated to Firestop. We're fully focused. We put all of our research and development into those systems that Dan just showed you, into the products like E-wrap and all of our other fire stopping products, and also our digital tools and our resources that we have available that we're going to show you. But this will get you access to everything that we're about to roll through there. So Dan, if you don't mind, next slide there. First and foremost, what you want is the system search and submittal builder. You can't install Firestop until you have a system, and this is how you're going to find the STI systems. If you are on Google or Apple, you can download the app. It's awesome. It's also available on our main website at stifirestop.com. You can just search in the upper right-hand corner for Find Firestop Systems, and you'll be able to search from over 1,500 systems that we have there, from all these endothermic wrap systems to regular through penetrations and joints as well. And you can build full submittals on there. And as long as you have an Access account, everything is stored right in one place for you. Access will also get you access to these fine folks. This is our engineering service team. They're a subset of the engineering group. They're the industry's best. They have close to 300 years experience, what you see up on the screen there. And they're always there when you need them. They're available Monday through Friday, 7 a.m. to 7 p.m. And they can get you any technical inquiries, anything, lead letters, engineering judgments. Typically, we turn those in 24 hours or less. Access will also bring you over to a lot of our digital resources. If you are a specifier designer, we have guide specifications. So if you're maybe using the old cut and paste method, or you want a review of your specifications for Firestop, give us a shout. We do free reviews of your spec, and we also have all the different sections and divisions for editable documents in Word format that you can use, cut and paste that. That's the most updated, so make sure that you're using that. We also have BIM objects in the Revit families. This is great for architects and engineers to import into their building models. The Autodesk Revit has specialized software that will, help you get this information into those models. And then it also works seamlessly with our Firestop Clash Management that you see up there. That's a powerful plugin for the Autodesk Revit family also. It uses clash detection to identify when you have penetrations or joints, and it'll actually select the systems for you. And then it'll make it very easy for you to put the systems on your drawings. So we have all those digital tools available for you designers out there. Firestop Locator, back up one time, Dan, real quick. Just want to tell everybody about the Firestop Locator. This is a great construction document tool that we have for Firestop systems, penetrations, joints, even doors and dampers, things like that. You can track. This is a great tool for contractors out there to, like I said, document the work that you've done and hand it over to an inspector, and it makes inspection very easy. All right, and this is a great slide now. We're offering a login and learn. So if you are here for continuing education credits, if you are with an architectural firm, we have a lot of awesome presentations that we can do specifically for you, customize them for you, get you credits for your entire firm. So that QR code there will take you to a forum. So if you're interested in having us, schedule a time that's mutually agreeable, we have all of these great presentations that you'll get 1 credit for. So they can all be done within 1 hour. So head on over there. And if you can't do it as a virtual lunch and learn, they are also available, as you see down in the bottom there, on our Firestop University. So you can do those as you please at your own pace. And then finally, as Christina mentioned at the outset here, we are going to be sending you a Credly badge in addition to your certificate and the recording and everything. this is a great way to share your credentials as far as your what you've learned about Firestop. So this is something that you may have seen on LinkedIn. People are sharing these all over the place. So be on the lookout for it. You should get that in the coming days as well. So now we have about 5 minutes until the top of the hour. This is a great time to take a break. So what we're going to do is we're going to take a 5-minute break, and we'll get started right at 2 o'clock Eastern time with Aaron Alterman's presentation about the basics of perimeter fire containment. So Dan, I just wanted to say thank you for your time, and feel free to say goodbye to the fine folks for now.
No, thank you guys for being here. If there's any other questions that we missed, feel free to send me a DM on LinkedIn or an email. I'm happy to address any questions that we couldn't address here today.
And again, so Dan will get forwarded a list of the questions that he was not able to address today. So be on the lookout for an email from him. We'll get that over to him today as well. So now we're just going to take a 5-minute break. I'll drop that in the chat so everybody knows that we didn't go anywhere. So if you're listening, just take a 5-minute break, grab yourself a drink. We'll be right back at 2 o'clock Eastern.
Okay, with it being 2:00, I believe we are ready to roll into our next webinar. Our next webinar is entitled The Basics of Perimeter Fire Containment, and our speaker is Aaron Alterman. I guess I'll go over the housekeeping items one more time, just for anyone who has joined us. The chat feature will be disabled during this session. And if you have any questions, to please put them in the Q&A section, and we will review them at the end of this webinar.
All right. Thank you again, Christina. So as the industry changes on an almost daily basis, understanding the basics of perimeter fire containment is essential in the design phase in order to eliminate costly changes, delays, and compromised life safety requirements during construction. Our presenter today is Aaron Alterman, facade and curtain wall specialist for the Central US and Canada. And Aaron will help us to eliminate the confusion associated with the different aspects of perimeter fire containment systems while outlining their importance in both life safety and code compliance. Once again, this presentation has been developed by STI and it is copyrighted, so please do not reproduce, redistribute, or display any material without contacting us first. This course has also been approved for one learning unit, HSW, with AIA, and has also been registered with ICC. And once again, as part of the continuing education requirements, here are today's learning objectives. In order to receive credit, be sure to stick around where we're going to be asking you to participate in that poll once again. So you'll receive credit and you'll know a little bit about the following. You'll be able to recognize the basics of curtain walls and how they perform in a fire. You'll be able to identify IBC and state building codes as it pertains to fire containment systems and their development. You'll be able to describe the impact of the standards and new code requirements, and you'll be able to identify the basics of non-backpan perimeter fire containment. And with that, Aaron Alterman, the floor is yours, my friend.
Well, thank you, John. Appreciate the fine introduction. I'd like to welcome everyone today to today's curtain wall training, and thank you for the opportunity to speak with you. As John and Christina mentioned, my name is Aaron Alterman, and I'll be your presenter today. I'm the curtain wall and facade specialist for the Central US and Canada for STI, of course. Today's presentation has been developed from overwhelming requests for an updated basics of curtain wall. And the presentation takes into account some of the most recent requirements and changes to the industry. This presentation is designed to assist you in understanding the updated requirements of perimeter fire containment systems, as well as how to avoid headaches and delays down the road that cost you money. Our discussion topics today will cover a brief introduction of what curtain walls are, the evolution of code consistency, the importance of testing for perimeter fire containment systems, and a detailed overview of the ASTM E2307 and the ISMA, and understanding how to read tested designs. We're also going to talk about designing and installing for success with key design and installation points for non-backpan aluminum frame systems, and meeting the next set of challenges to the industry. And of course, we'll give you an STI update, and if there's time, Q&A. All right. Let's get started here. As we continue to reach higher and higher throughout the world, perimeter fires or curtain wall fires continue to be an increasing problem. Whether they are contained and controlled or devastating and heartbreaking, perimeter fires change the way buildings are protected. The major fire in Grenfell or London has impacted many of the codes worldwide and brought to light the growing concerns of curtain wall consultants as curtain walls continue to evolve and pose unique challenges. This has made an impact on how people protect high-rise structures. Unfortunately, we continue to have fires on a regular basis. Some examples of high-rise fires with injuries and deaths and property loss in 2020 include fires in Hawaii, Chicago, Los Angeles, New York City, and there was one last October in South Korea. And you basically can see pictures and stories of high-rise fires every day if you dig deep enough. But we're trying to avoid that. So let's do a quick review on curtain walls so we are all on the same page. Right, curtain walls are a non-structural, non-fire rated perimeter wall, most commonly found in commercial, multi-story, or high-rise construction. They serve as an exterior skin that provides protection from the elements and helps provide a comfortable environment inside the building. Curtain walls have many different appearances, but its characteristic makeup features narrowly spaced vertical and horizontal aluminum framing with glass, stone, metal, or composite panels. So what does non-structural mean? Curtain walls are rigidly attached to the floor slab with an anchor system. The curtain wall facade does not carry any dead load weight from the building other than its own dead load weight. The curtain wall transfers wind and gravity loads to the main building structure through connection at floors or columns of the building. Since the curtain wall is non-structural, it can be made of lightweight material like aluminum that reduces construction costs. So let's review the components of a traditional curtain wall aluminum frame system. First, you have the anchor slab, which will be located either at the top or the bottom. First you have the anchor system, which will be located either on top of the slab, the edge of the slab, or completely under the slab. The curtain wall consists of vertical mullions and horizontal transoms. The spandrel area can be glass, metal, stone, or ACM panels. And the last is the vision glass area. When considering how to protect a curtain wall assembly, all of these components have an impact. Location of the anchor system, transom spacing and height off the slab, and mullion spacing are all basic considerations that have to be taken into account for proper protection. Okay, let's briefly discuss the evolution of code consistency. A good starting point is always to have a solid understanding of the code requirements. In the perimeter fire containment world, we use the 2012 IBC version of the code that outlines the requirements of the new ASTM standard, and it's eliminated much of the confusion of earlier versions. The great news is that the codes have finally established consistency with the adoption of 2015 and 2018 IBC codes, as well as multiple state codes being revised. The 2012 code adopted specific language to outline the requirements and further eliminate confusion that future versions have built upon. As you know, the protection of voids is mandatory in all building codes, with the IBC addressing specific ASTM E2307 requirements. Section 715.4 addresses the voids created at the intersection of a non-rated exterior curtain wall and a rated floor roof slab to prevent the interior spread of fire. Voids must be sealed with an approved system to prevent the interior spread of fire, not just materials with known fire-resistant properties. The system must be securely installed, i.e. mechanically fastened in place. Systems must be tested in accordance with ASTM E2307, which we will cover in detail shortly. And the system must provide an F rating equal to that of the floor or roof deck. Canada has also adopted the ASTM E2307 requirement into the 2018 S115 Canadian Code. The adoption of the ASTM E2307 requirement into the Canadian Building Code was delayed due to the pandemic, but it's scheduled to formally happen in the coming year. So we'll be waiting for that. And this is a slide taken from the 2018 S115 code. And you can see ASTM E2307 is referenced in section 9 as the standard test method for perimeter fire containment systems using the intermediate scale multi-story test apparatus, what we call the ISMA. And we'll get into that in a moment here. But you can see in the Canadian code that it's all over it. So let's get into our discussion of the ASTM E2307 standard and the ISMA and understand how to navigate through a tested design. So what is ASTM E2307? Well, basically, it is the standard test method for determining fire resistance of perimeter fire containment systems using the intermediate multi-story test apparatus. This is a very severe and difficult test to pass, and it differs in three critical ways from how standard construction joints are tested. Number one, the assemblies are tested between a rated floor roof barrier and a non-rated exterior curtain wall assembly. The test method measures the performance of the perimeter fire containment system and its ability to maintain a seal to prevent fire spread during the deflection and deformation of the exterior wall assembly. The curtain wall and the joint are burned from below and also from the exterior to mimic how high-rise fires perform. Compartmentation is a key component of fire life safety. This is the process of dividing a building space into smaller units by constructing rated boxes to limit the spread of fire, toxic smoke, and gases to their point of origin. This allows occupants to get out and first responders to get in. Obviously, this is critical in fire life safety, but in curtain walls, structural integrity is just as critical, because if the wall comes off the building, the joint goes with it. So we must protect the key components of a non-rated curtain wall system as long as possible. The fire will attack any voids at the floor line on the interior side while breaking out the vision glass on the floor below. The fire will also attack the framing system, which is typically constructed of aluminum. Again, if we don't protect the critical components of a non-rated curtain wall properly, the entire wall will fail. And you can see from this photo, structural integrity is completely lost. So it's important to note exactly how critical and severe the ASTM E2307 test standard is for perimeter fire containment systems by looking at the ASTM E119 time temperature curve used during the test. Note the melting points of rigid foam panels at 300 degrees Fahrenheit, spray foam at 392, zinc melts at 790 degrees, and alloy begins to soften at 865, will begin to melt at 1220 degrees Fahrenheit. So if we are running a 2307 test at a third-party lab that consists of aluminum framing, we will start to lose the lower framing members 9 minutes into the test, and we are just starting a critical stage of protection that must last for another hour and 51 minutes. Let's look at the impact of the test let's look at the impact of the 2307 test in the ISMA on a recent test we conducted. On the left, you can see the multi-story wall prior to the start of the test. And on the right, you can see the very start of the test with the internal burner just lit. Here, the internal burner is gaining intensity very quickly. You can see from different angles on how that is ramping up. Here you can see the internal burner really cranking about 5 minutes into the test. Next, the exterior window burner is lit, and the test begins to ramp up quickly. The wall is now under attack from fire on the interior and exterior sides. Here you can see the intensity of the test has progressed significantly. We start to see flames as high as 14 feet. At this point, we start to see critical components of the wall start to show fatigue under the temperatures and pressure of the time temperature curve. As we talked about earlier, roughly 9 minutes into the test, you can see lower horizontal framing members or the transom start to melt, deflect, and twist. Moments later, you can see the lower framing of the wall giving way as the flames eat through the wall system. And to document the extreme heat and pressure of the full-scale ASTM E2307 test, you can see vision glass used in this design has melted and is running down the exterior of the wall assembly. This is not a common occurrence, as the glass generally breaks or shatters during the test, but it does demonstrate the extreme temperatures the wall is subjected to. Here you can see the impact of the ASTM E2307 standard at the end of the test. Critical components of the wall system have been lost, and the assembly is glowing red hot. And here you can see the impact of the vertical framing system at the floor line and anchor system in direct correlation to the location of the exterior window burner. And it's important to note that the wall will twist, warp, and come apart below the floor slab. The key is to maintain integrity of the wall system at the anchor points at the floor slab and maintain integrity of the wall system above the floor slab. Inside the chamber, you can see that the void has been subjected to severe heat and movement, but the combination of a proper installation of the mineral wool and Firestop spray have performed perfectly. So with that, we pass the test. And once we have a successful test for the ASTM E2307 test requirements, we can publish a listed and tested system. So STI utilizes the best aspects of both labs for tested designs that are proven under real world fire conditions. Both Intertech and UL test to the same ASTM E2307 standard, but there are unique aspects to both labs. Curtain wall consultants utilize UL for many reasons, such as the ISMA configuration for backpan designs, anchors tested in the designs, and realistic movement requirements. Intertech has advantages for specific designs, such as vision glass, hybrid window walls, and wider mullion spacing. We use the best aspects of both labs in our tested designs to give the ability to produce real-world perimeter fire containment systems. So once you have a successful test, you're given a system number. Each lab has an alphanumeric numbering system, and it's pretty simple to understand how these systems are labeled once you've read through a few. But I'll quickly break down what everything means in a UL system, and then we'll take a look at Intertech. So for perimeter fire containment testing, the first two alpha characters with UL are CW, which obviously stands for curtain wall. And this means that the assembly has been tested per the ASTM E23 on the ISMA standard. The second set of alpha characters will be either an S or a D, referring to either static or dynamic design. And please note that in a perimeter fire containment system, a static system is completely acceptable. Most people are familiar with the static and dynamic movement of head of wall joints, where the dynamic movement is either compression or extension. In perimeter fire containment systems, the movement is a 5% vertical shear only. The numeric components addressing the gap width in the system and the test numbers in that series. So the first number references the width of the gap between the curtain wall and the edge of slab. So the 0 series are for joints up to 2 inches wide. The 1000 series are for joints up to 6 inches. And the 2000 series are for joints up to 12 inches wide. The last three numeric components list the test number in that series. So this assembly is the 41st test run for a perimeter fire containment system for a joint width of a max 6 inches as tested per the ASTM E2307 standard. One more thing to note, the last 3 digits are a sequential proprietary number system that is unique to the manufacturer who passed the test. So tests may be similar from manufacturer to manufacturer, but each one will have their unique number. So at Intertech, it's even easier. In this case, system STI BPF 120-04 is broken down as follows. So the first alpha letters there are STI for the manufacturer. BPF means barrier, perimeter fire, tested per the ASTM E2307 requirements. 120 is in minutes, so an hourly rating of 120 minutes will give you 2 hours for your F rating. And 04 is the 4th system tested in this grouping. Again, unique to STI, this particular test. So having a strong pedigree of tested designs to choose from is critical in the design phase or installation phase of perimeter fire containment systems. The value of the tested systems are always recognized and respected by architects and inspectors, and it will limit the project delays by eliminating any concerns you might have with that system. It will also save money by keeping the project on or ahead of schedule and limit your liability and exposure. As we have discussed, tested designs will work in real fire conditions. So let's take a look at some pictures of a project that we were involved in. So if you look at the spandrel panels, you can see exactly where the most severe area of the fire was, right in here, if you can see from my cursor. On the right, you can see the panels starting to melt, and on the left, you can see the panels gone and only the spandrel insulation is left. Moving further to the left, you can see only the section of spandrel and safety insulation at the floor slab that has been held in place by the stiff back angle. On the floor where the fire broke out, you can see the failure of the wall system, which is exactly what will happen. The aluminum framing, vision glass, and spandrel panels are completely gone. But on the floor above, the anchor and the aluminum framing are all intact and protected. The perimeter fire containment system did its job. Now, in addition to this, so this happened in New York City during construction of a building, and so thankfully no one was hurt. But after the test, during the walkthrough with the fire marshal, they let us know how pleased they were to see this, because by keeping this framing intact and keeping the building together, it's just an added layer of safety to the first responders, knowing that they are not going to have the building topple on top of them as they are running in to save lives is a big win for us. So tested systems work and they do their job. And here's an example of that. So let's continue on to our next section, which is designing for success. In this section, we will discuss the key design and installation points for non-backpan aluminum frames designs and wrap this section up with some key challenges that we consistently face and how to address them. So in this section, we'll discuss the requirements of the components of the tested design, including the following: why we use light gauge metal for spandrel insulation attachment, the proper orientation of the mineral wool in the safing slot, role of mullion covers, and the role of the tested Firestop spray. So every tested system for aluminum frame designs require 5 basic features. Spandrel insulation is mechanically fastened to the frame or the steel backpan. Number 2, a stiffener or reinforcing member installed behind the spandrel insulation to maintain the compression of the safing in the slot or void area. The mineral wool in the safing slot or void is installed with the grains running vertically and to the required compression listed in the system. Mullion covers installed above and below the floor slab where required, and safing shelves installed on backhand designs for specific system requirements. And then installation of the tested Firestop coating is shown in the system is the last piece of the puzzle there. So why do we use light gauge metal, angle, hat channel, or insulation hangers in the tested designs? Well, light gauge metal is required for the following reasons. 1, it's to keep spandrel insulation in place to maintain the integrity of the wall system in the fire. It's to meet the 715.4 code requirement of securely installed, and is required in all UL and Intertech tested designs. Here you can see the role of the light gauge continuous angle that is fastened to the framing, and the spandrel insulation is secured to the angle with drywall screws and fender washers or cuphead weld pins for the system requirements. Note the melting of the vertical mullions and the bowing of the frame system at the bottom where the transom is burned out. There are many tested options, including installing a continuous angle, hat channels, or insulation hangers. And the industry now has high-performance insulation hanger assemblies that are quickly becoming the preferred option for both field and shop installed installs. The development of high-performance insulation hanger systems are changing the way spandrel insulation is installed. These new systems provide substantial labor savings, and the designs have major advantages over traditional methods, including the fewest number of screws installed into the framing, or in many cases, no screws at all, allows proper internal drainage within some of the new framing systems, and these systems excel in wall systems where there are steel liners inside the mullion or blast-proof walls with steel reinforced mullions. Light gauge metal is also used to support the compression requirements of the mineral wool in the void or safing slide. Please note the spandrel insulation is not fastened to the angle. It simply sits behind the spandrel insulation. You can see galvanized angles used on the left and hat channels used on the right. They are generally located 2 inches from the top of the floor slab. Here you can see the stiffener keeping compression of the mineral wool in the void, even as the curtain wall framing comes apart below the floor slab. Let's see if this works. Yeah, see, there's the framing eliminated there. You can see the stiffener is keeping that compression even as it all comes apart. Okay, the proper orientation and compression of the mineral wool in the void or safing slide is often misunderstood. On the left, you can see the proper method with the grains running vertically along the slab, and on the right, you can see the incorrect method with the grains running horizontally. You can see in the 2 images on the right how the grains running horizontally do not compress and buckle, which will cause fatigue to the joint system. In the images on the left, you can see how the mineral wool is turned with the grains running vertically. The mineral wool compresses like an accordion, allowing the mineral wool to rebound against itself to maintain proper compression. Please note that when mineral wool is installed correctly, there are no additional supports or old-style insulation Z-clips needed to support the safing. Our current systems are tested up to a max 10-inch width joint. Here you can see safing being installed properly at the slab edge. All right, let's take a few minutes to discuss mullion covers. So traditionally, mullion covers have been used to provide a bridge between the spandrel insulation over the exposed mullions. They are designed to stop the transmission of heat through the mullion to the knee wall. Mullion covers are cut from foil-faced spandrel insulation and installed above and or below the floor when necessary and through the safing slot. There have been many advancements in the requirements for mullion covers. Many of today's high-performance tested designs only require a mullion cover below the floor slab. In some cases, mullion covers are not required at all for the test. They can simply be added for thermal requirements when needed. It is always recommended to refer back to the tested design for specifics on mullion cover requirements. So let's go over the role of the Firestop coating. Icing on the cake, as I like to say. It's the final step in a compliant tested design and acts as a glue to keep the system intact on the top side of the floor. More importantly, it stops the propagation of smoke, fire, and toxic gases through the mineral wool in the safing slot. Stopping smoke will save lives when you have a compliant system, but we continue to see damaged or incorrect installations quite often. And this could be due to a number of factors. The spray could be damaged because of exposure to water before it's cured, hard or brittle compounds that can crack once cured, incorrect caulks that have washed out due to water exposure, or untested solutions like simply stuffing pieces of mineral wool insulation into the void. That will not work and not give you a compliant installation. And as you know, 70% of all fire-related deaths are due to toxic smoke and gas inhalation. So it's even more important that Firestop coatings are used properly to maintain that seal at the edge of slab. Most occupants have already perished from smoke inhalation by the time the flames reach them on the upper floors. So again, installing a code compliance system is absolutely critical. Right, so our last section is meeting the next set of challenges from curtain wall consultants, architects, and code officials. As we discussed earlier, anchor protection is a very critical component of any perimeter fire containment system. Remember, if the anchor fails, the entire wall goes with it. So UL has just adopted testing requirements in the XHDG guide for all manufacturers that require dead load anchors exposed to direct fire must be protected. These anchors must be protected for the hourly rating of the floor slab. And UL has also adopted a new category, the XHDI guide, that clearly defines what is an acceptable level of anchor protection. This is a mandatory requirement of curtain wall consultants and designers, and the codes are adopting language to incorporate consistent requirements. Here you can see two examples of protecting the components of a top of slab anchor on the left and a face of slab anchor on the right. In some cases, we can allow the fist slider assembly to extend below the safing a max of 2 inches without additional protection, which we have in our UL systems CWD 1044 and CWD 1045. While other designs fully encapsulate the anchor system, allowing the mineral wool to extend below the floor slab by a max of 2 inches, is detailed in our system CWD 1050. In conditions where the anchor plate or assembly is fully exposed on the underside of the slab, specific solutions were needed to be created to pass the rigorous test standard. Here you can see an anchor protection product that is simply shot into the deck from below, providing complete protection for the anchor. UL has also started to publish specific tests incorporating these new requirements. For example, our UL system CWD 1032 is the only tested design able to treat a fully exposed underslab anchor. One quick note before we go further: because the glazers have all types of anchor systems, our curtain wall team spends the majority of our time assisting curtain wall consultants, architects, glazers, and Firestop contractors in the proper protection of their anchor systems to ensure that the entire wall stays intact in the event of a fire. Fortunately, we are brought in too late on some projects, and due to a variety of reasons, it can be difficult to address the anchors properly. So regardless of whether you are a general contractor, architect, glazer, or Firestop contractor, please get us involved early so collectively we can address the anchors properly. Another issue that has become a concern for code officials, architects, and consultants comes from the use of newer framing systems. Here you can see an example of what's called a single chicken head design. This design creates an opening in the face of the framing system at the stack joint, and this will allow smoke, toxic gases, and flames to travel inside the mullion vertically to the floors above. A double chicken head design will eliminate this issue completely. So the proper way to address this is use of a specific type of mullion plug that has been tested in these conditions. An important point to note is that the mullion plugs would have to be installed as the units are set. Once the units are in place, there will be no access. So before we end this section, I just want to emphasize again, just like anchor protection, curtain wall team spends a lot of time addressing these situations. So please feel free to get us involved as early as possible so we can properly address these conditions. The last area of major concern revolves around the development of hybrid window walls, crossover window walls, and notched vertical curtain wall systems that have created huge headaches for curtain wall consultants, architects, and code officials. The continued development of hybrid window walls makes the already difficult task of developing real-world perimeter fire containment systems even more difficult. Current systems are pushing the envelope of design, creating issues in the field due to unique fabrication and installation requirements that render traditional fire stopping methods useless. Because of their performance under fire conditions, ASTM E2307 tested perimeter fire containment systems are critical for these growing wall types. As we reviewed, the protection of voids is mandatory in all building codes, with the IBC addressing the specific ASTM E2307 requirements. As I mentioned earlier, Code Section 715.4 addresses the voids created at the intersection of a non-rated exterior curtain wall, or in this case, window wall, and a rated floor or roof slab to prevent the interior spread of fire. Voids need to be sealed with an approved system. Systems must be securely installed, i.e. mechanically fastened in place. Systems must be tested in accordance with ASTM E2307 and must provide an F rating equal to that of a floor or roof deck. And most are familiar with these requirements for traditional curtain walls, but many are not as familiar with the newer hybrid window wall designs and the issues they present. But as you can see, the framing creates voids that must be sealed both between the edge of the slab, the closure piece, and between the framing above and below the floor slab. Once again, as with traditional curtain wall assemblies, the voids created at the intersection of the exterior wall assembly and the rated floor or ceiling assemblies need to be sealed with an approved system to prevent the interior spread of fire. They need to be securely installed, tested against the ASTM E2307 standard, and provide an equal F rating to the floor or roof deck. Whether it's a traditional double frame system or a vertical notch flat plate anchor system, voids are created and must be addressed by the code. The point is, regardless of the frame type, hybrid window walls, crossover window walls, vertical notch curtain wall systems create voids that must be addressed per code requirements. Right, so that's going to conclude our AIA section of the presentation, and we are excited to give you an update on what STI has been working on these last few years. So we want you to know that you are not alone in your struggle to properly fire stop your buildings. STI is your global fire stop solutions partner. We own over 60% of the perimeter fire containment systems tested at UL and many more at Intertech. But having the greatest number of systems isn't enough. As we've talked about, it's all about real-world testing. STI has developed complete tested solutions for backpan designs, non-backpan designs, all vision glass, hybrid window wall, and of course, we offer complete tested coverage for precast panels, EIFS, and GFRC designs as well. Because in a project, you may have a multitude of wall types, so we want to make sure we have a system for each one. STI has also invested in the development and testing of the industry's most successful products for perimeter fire containment, including water-based and all-weather high-performance fire stop sprays for perimeter containment, the quick clip system that is already becoming the standard procedure for shop and field installed spandrel installation, and the industry's first ASTM E2307 tested solution for hybrid window walls, crossover window walls, and vertical notch curtain wall systems using our window wall gasket. As we discussed earlier, STI leads the industry with the only tested designs incorporating anchor protection. Again, you can see two examples of protecting the components of a top of slab anchor on the left and a face of slab anchor on the right. And in some cases, as I mentioned before, we can allow the fist slider assembly to extend below the safing line of max of 2 inches without additional protection. And that you can find in our system CWD 1044, CWD 1045, and STI BFP 120-07. While other designs fully encapsulate the anchor system, allowing the mineral wool to extend below the floor slab a max of 2 inches, as tested in our assembly CWD 1050. As we looked at earlier, STI has developed many tested designs for top of slab and face of slab anchor protection. But we have also developed the first and only tested solution for 2 hours on a completely exposed under slab anchor system using our CP100 product. In addition, we have worked closely with our glazing and consultant partners to develop the industry's first UL-tested solution for sealing the inside of mullions. It's a two-part foam incorporating an intumescent technology that will expand 11 to 14 times for complete protection. Requires no wet sealant or flammable foam in a can, simply installed as the units are being set in the field. It's got a leakage rating of less than 1 CFM, a noise reduction coefficient of 0.75, and 0 VOCs. So it's obviously a UL listed product. And these are custom cut for the project, and we will work with the design team early on to ensure a seamless install. As mentioned earlier, hybrid window walls, crossover window walls, and vertical notch curtain wall systems have become a major challenge. And STI is proud to introduce the industry's first ASTM E2307 test for hybrid window wall designs. Here's our assembly STI BPF 12004. It's the industry's first true hybrid window wall design, and it addresses the voids between the hybrid window wall framing and the floor slab. A max 2.5-inch void between the closure panel and the face of slab, and the system allows for multiple closure panels, including aluminum, glass, stone or terracotta, ACM, MCM panels, galvanized back pans, and in this case only, aluminum back pans. So we are excited to introduce 2 new hybrid window wall designs for vertical notch curtain wall systems incorporating several industry firsts. So STI BPF 12005 is a true cutting edge design offering the following advancements. It's the first ASTM E2307 tested solution incorporating a flat plate anchor system for vertical notch curtain walls. It addresses the voids between the flat plate anchor system and the top of the floor slab. Again, a max 2.5-inch void between the hybrid window wall and the base of the floor slab. It allows for optional weather seals. This is the first system to allow any exterior cladding system that complies with applicable building codes and regulatory requirements. And it also allows for any air or vapor barriers that complies with those applicable building codes and requirements as well. We also have a sister test to that, STI BPF 12006, which incorporates a knee wall and all the same cutting edge advancements of 12005. Right, but having the industry's best products, testing, and solutions isn't worth anything if you don't have the right people to support you. Because STI is 100% focused on only fire stopping, we can support market segments that have critical needs. Our curtain wall team works directly with our engineering group. As I mentioned, it works directly with our engineering group. And as I mentioned in the beginning, or Christina and John did, that I cover the central US and central part of Canada. Michael Zanatelli covers the western portion of the US and western Canada. And Eric LaCroix, who is the director of the curtain wall team, covers the eastern portion of the US and Canada. We have 50 years of experience between us. And as we have discussed, our role is to assist in the design of perimeter fire containment systems with architects, curtain wall consultants, glazers, Firestop contractors. Once the project has broken ground, we will then assist with the local STI personnel to help deliver a successful project. To make our partners' lives easier, we have developed what we call a Handbook of Solutions that focuses on the most cutting edge of STI's perimeter fire containment systems. It's easy to work with, so you don't have to search through 140 plus tested designs in our system search. It's broken down by wall types, insulation attachment methods, and anchor types. And it contains systems for backpan, non-backpan, all vision glass, short panels, hybrid window wall, and anchor protection designs. It's a digital, fully interactive book that has hyperlinks to the systems themselves, product information, etc. If you're interested in a copy, please put your email address in the Q&A, and I will happily send you one when the presentation is over. And STI's commitment to supporting our customers is never ending. We offer unmatched technical support from our engineering services group with over 250 years of combined experience through 2 U.S. offices. And they are available Monday through Friday from 7 a.m. to 7 p.m. Eastern. Our goal is a 24-hour turnaround time on engineering judgments, and we have immediate technical support available via our chat feature on our website. So let's see. So with that, we are ready for Q&A.
All right. Great job, Aaron. We are going to do the questions for you first, and then we'll do the questions for our listening audience. So we did have a few of them come in here. So we're going to get started. Christina, you want to grab that first one there?
Yeah, sure. What's the max distance between the curtain wall and the floor slab edge?
Well, that will really depend. We have our systems go for a max of 10 inches for that joint, but we have seen areas where it gets wider than that. So that would be a very specific thing that we would have to address individually. But for the most part, 4 inches is sort of the normal, and 10 would generally be the max in a sort of straightforward system. But again, if you have a specific issue on a project, please get us involved, and we will help you to find a solution for that.
All right, next question here. Does STI have a perimeter Firestop for glass, all glass, or floor-to-floor glass? I saw something about the all-vision glass in the Book of Solutions. You want to maybe talk about that one?
Absolutely. We do have a system. It's an Intertech system. I want to say it's 12001, but I should know that. But that is our all-vision glass system, and that requires basically a steel pan to be constructed to create an area of mineral wool that can be sprayed over to give you a tested design and Firestop seal at the slab edge for all vision glass. So yes, we do have one, and it is in our Handbook of Solutions, and it can also be found on our website under the Intertech tab if you're looking through our system search.
Yeah, we'll put that the QR code up again where you'll be able to find the system search and Submittal builder in just a few minutes. So I'll ask this next question here. I already know the answer to it. Does STI have their own applicators on site? But maybe you want to talk about the types of contractors that do this type of curtain wall fire stopping.
So, STI as a manufacturer, we don't directly install any of these products ourselves. We work with a great group of people all across the country, many specific to curtain wall installations. And, depending on the region you're in, we have many partners in every part of the U.S. that we would be happy to help put you in touch with. So, and we work with I don't want to say countless, but we work with dozens of people on a daily basis to help find solutions for their perimeter fire containment needs. Put it that way.
All right, great job. Christina's taken note of everybody that wants that solutions book, so feel free to drop that in the Q&A. I'll finish up a couple more questions that we have here. They're asking about, does STI have a cover plate over the finished spray? I mean, obviously we don't have it, but can you talk about how the spray is sometimes protected?
Well, there are some systems out there from different manufacturers that do require a steel plate to go on top of the Firestop coating. It's protecting that before the building is closed up is critical. You want to make sure that all the hard work you put into installing the saving insulation and getting that Firestop coating on there, you want to make sure that that is left intact once you finish your work. You can do a variety of things on site to protect those areas, but our systems generally don't require any additional material on top. Rope off that area, rope off the wall or whatever section you've just done, and hopefully nobody will put a ladder through the edge of slab area and make you have to go back and redo it. So,
All right.
not the best answer, but it's an answer.
It is. Oh, good, Aaron. We have one more here. I'm going to ask it a little bit differently than how it was written, because it says, how many times does it take to pass a test for the first time? Hopefully only once. But can you talk a little bit about STI's testing and how we work with manufacturers? Yeah, I've been very fortunate over the last several years to be involved in several tests and to see how they work. It is a very intense process. Number one, there's a lot of things that have to come together. These multi-story tests first of all, a wall has to be constructed. So that's part one. Then we have to we have to book time with the testing labs, and many of them are booked out months in advance. So there's the coordination of that. Then the cost of running these tests start in the neighborhood of $40,000 to $50,000, and it can be higher. So we want to make sure that we have all our T's crossed and I's dotted before we even get to the lab, because if you fail and have to start over, all those things, all those factors, the wall construction, the installation, all the coordinating has to start basically at square one. So failing a test is not fun. We don't want to see that happen, but it does happen, and that's how you learn. And hopefully you only have to run one more. You learn enough from the data on the fail test to be able to make it work properly on the next go round. But we've certainly been involved in failures, and we have taken the knowledge and gotten it to pass. But these are very costly, very time consuming, and frankly very dangerous as you're working with live fire. So it can be a great undertaking to do these, but we are 100% committed to our testing and our lab partners, and we're working with them on a weekly and monthly basis to continue to expand our library of tested designs and make sure we are keeping everything up to date. So hopefully that helps. Great answer, Aaron. You made up for that last one. Okay, good. Thank you. All right, and that's all the open questions we have right now. Now we're going to ask you a few questions before we let you go. And this is to test your knowledge. Christina will launch the poll right now, and we'll walk you through the 5 questions that Aaron has for you here. Question number 1, what is the horizontal component of a curtain wall system called? Is that the mullion, the transom? We're talking about spandrel glass, vision glass, or is the anchor? Make your choice now. We'll move on to number 2. What is the standard test method called for determining the fire resistance of a perimeter fire containment system? Is that ASTM E119? Is it the ISMA? Is it ASTM E2307? Is it the IBC, or is it S115? All right. Number 3, Aaron, if you don't mind, maybe click that next slide. Yep. Great. According to the new code language, which of the following are true? Voids must be sealed with an approved system. Systems shall be securely installed. Tested in accordance with ASTM E2307. Provide an F rating equal to the floor, or is that all of the above? All right. Number 4. What type of movement is tested in dynamic perimeter fire containment tests? Is that 5% shear movement only? Are they static? 24%? Is it sway, or is it compression and extension? And then finally, number 5, what is the maximum gap width tested for a perimeter fire containment assembly? Is that 25 inches, 4 inches, 10 inches, 1 inch, or 8 inches? Make your final selections now. We'll go over the answers briefly. All right, Aaron, if you don't mind, go back to the last slide. Christina, launch those results and we'll take a look. The horizontal component of a curtain wall system is called a what, Aaron? What's it called?
It's a transom.
It's a transom. So it's not a horizontal mullion?
No, sir.
No, sir. All right, that horizontal component is transom. 54% of you got it right. Number 2, the standard test method for determining these systems is going to be the ASTM E2307. I think Aaron said it 730 times during the presentation. So kudos to the 84% of you. The ones that chose E119, that is the time temperature curve though. So I think you did mention that one as well. So
Correct.
That definitely factors into the 2307. Number 3, Aaron, if you don't mind, next slide. According to the new code language, which of the following are true? And that would be yes, all of the above.
Correct.
Number 4, what type of movement is tested for dynamic tests? We're talking about, oh, wow, okay. I think the answer is 5% shear movement only. Is that correct, Aaron?
That is correct. That is correct.
So only 24% of you got that one right. Good question there. Good, tough question. The compression and extension, I think that people are thinking about is for those head of wall joints. And
head of wall is where compression and extension comes in. Curtain walls move a lot differently than those type of joints. So vertical shear is going to give you, your sort of thermal expansion, your wind sway, things like that a building encounter. It's not very much. It's 5% of the width of the joint. So that is that's how we get to that number, and you can see that listed on most, if not all, of our tests.
All right. Great job. Thanks for providing some of the context to that tough question. And then the last one there, what's the maximum gap with tested? 10 inches. Is that correct? 53% of people said that one.
That is correct.
And if you
you put an asterisk by that because, we can work with you if it's more, but 10 is generally what our maximum width is in our tests.
All right. Very good. All right. And then we'll just roll through these last slides. We don't want to keep people too much longer than 3 o'clock. So again, this has been brought to you by STI. We're fully focused Firestop manufacturer. And we'll just kind of show you where you can find all of this great information. Again, this is Access STI. I highly recommend that you create an account for yourself if you don't already have one. You can watch some of these trainings back, get some additional trainings, and then put all of your submittals and engineering judgments stored in one place. The next slide will be for the system search and submittal builder. Again, if you are a contractor, designer, specifier, and you want to know where to find these systems, here's where you can do it. These will take you to the app stores, so you can download it on your phone, or you can get the system search and submittal builder off of our main website, stifirestop.com. And that's where, again, you'll be able to find all of the digital resources for designing, whether it's specifications, your BIM objects for your models, Firestop clash management. Again, this will detect clashes, so it will pre-select systems for you, so it takes a lot of the guesswork out of there. And then obviously Firestop Locator is a great tool for documenting all of your penetrations, joint systems, especially if you're in a healthcare facility, for instance, where you may be inspected every year or 3 years. And then 2 more slides. Here we go. This is our login and learn. I mentioned this a little bit earlier. So if you are an architect or you have a firm and you'd like to have one of these presentations done for you, we're doing them virtually right now. Depending on where you are in the world, we may be able to come and do them in person if you're accepting guests at this point. But obviously, due to the current situation, virtual is the way to go. So if you'd like a fully accredited presentation, one of these topics of interest to you, you can schedule that for your firm. Or again, as I mentioned, you can visit the Firestop University on our website and watch any of these trainings back to receive your credits that way. And finally, once again, you're going to get another badge if you're on for this long. In addition to the one that we talked about earlier, this is going to be the one that you're going to get for this presentation. So feel free, again, to share it across the social platforms. It's just going to show your credentials as far as your knowledge in the fire stopping industry. And we definitely appreciate any shares, likes, comments, if you see them out there. Aaron, you want to take us home? You got a lot of requests for books, buddy. You're going to be busy sending some emails out after this one.
I just wanted to thank everyone for their time today. I hope you learned a little something. If you have any questions whatsoever, don't hesitate to shoot me an email to aalterman@stifirestop.com. And I look forward to working with y'all, hopefully seeing you in person or at least virtually in the coming year. And Happy New Year on everyone. Thank you again.
Thanks again, Aaron. And Christina, just remind the folks what you're going to be sending them.
Yeah, so keep a lookout for those Credly badges. Like John mentioned, we love to see them on social media. Also, we will be sending the certificates of attendance for those of you who attended at least 75% of the live webinar today, as well as a recording to all who registered. Just give us about 7 to 10 business days for the generation of that stuff, and we'll get it out to you.
And we do have one final webinar tomorrow. So if you got an email about this one, you'll be getting an email about that one. So hopefully you'll join us. It is the 30th of December, so I don't think I'll try to sneak another one in there, Christina. We'll let you break for New Year's Eve. But thanks again, everybody, and stay safe out there.
Thank you.